Hi, welcome to another lesson at Edu Solutions Institute. So today we'll be looking at IB Physics projectile motion calculations. Now we have done projectile motions in the past weeks where we looked at the theory behind objects moving in a projectile motion. Now objects moving in a projectile motion will exhibit both an X motion and a Y motion. So we're going to look at one or two questions to help us to understand how to apply these formulas to different situations in projectile motion. So here we go with the first question that says, 2 seconds after being projected from the ground, a projectile is displaced 40 meters horizontally and 54 meters vertically above its point of projection. Now, based on this, let's do a little sketch, right? So if we have the ground here and something is projected at an angle upwards, we're going to give it a time. So in this place, horizontally, it was displaced in an X plane, and then vertically it was displaced in a Y plane. So what do we know? That horizontally, it's 40. So that's 40 meters for X, and Y would be 53 meters. And the time it takes to do this was 2 seconds. So the first part says calculate the horizontal component of the initial velocity of the projectile. Right? Now what we should know from this is that the X direction is equal to UXT, which means that UX does not change because there is no acceleration in the X plane, because there is no external forces acting in the X plane. So therefore we can find UX, which is X over T, which is 40 over 2 seconds, which we get 20 meters per second. All right, so that's how we will know what the initial velocity in the X plane was. And then we look at the initial in the Y component. Now, how do we find that? We know that Y is equal to UYT plus half GT squared. Now we know Y is 53, right? We know UY is unknown. The T is 2 seconds plus half of G, which is negative 9.81, times T, which is 2 seconds squared. Right. Now if we work this out, we'll get 53 is equal to 2UY minus 19.62. We take the 19.62 over, so it comes 53 plus 19.62 equals, and we divide it by 2, and we get UY. So UY would be 36.31, which to smallest sig fig, which is 1, we get 40 meters per second. All right, so this formula is taken from the straight motion equation formula, US equal UT plus half AT squared. So because it has acceleration in it, we can use it for your Y plane, because Y has acceleration in that plane. So replace the X with the Y displacement. The U would be the initial in the Y axis times T plus half the acceleration, which is always gravity, times T squared. All right, we look at the next question that says, at the instance of projectile achieve its maximum height above ground level, how far is it displaced horizontally? Right. So what do we know when something is at its maximum peak? At its maximum peak, its Vy is going to be equal to 0. Right? So if we know the Vy is 0, we know the Vy initial, or let's call it Uy. We know the Uy is the one we just found, which would be 40 meters per second. We know its maximum is 0, right? And we know its g is negative 9.81. Then we can find the time it takes to reach the maximum height. Then we use that time to find the horizontal distance. So we go with a is equal to v minus u over t, which therefore t is equal to the v, which is vy minus uy over g. And that gives us 0 minus 40 over negative 9.81, and we get the time to be 4.08, which is 4 seconds. So it takes 4 seconds to reach the maximum height. Then we can find x, which is equal to ux times t. The ux does not change because there is no acceleration. So it's 20 times a time of 4. So we get 80 meters. All right. So that's a simple way of utilizing the equations for projectile motion. Now let's look at this set of questions as we close off for this session. So it says a lowly high diver pushes off horizontally with a speed of 2 meters per second from the edge of a platform that is 10 meters from the surface of the water. And what horizontal distance from the edge of the platform is a diver 0.8 seconds from pushing off. So let's say this is your water here, and the diver pushes off horizontally, and it tells us that it pushes off horizontally at 2 meters per second, right? Then it is at a y value. This y is going to fall 10 meters. So that means it goes down like this, right? So it says at what horizontal distance, which would be x, from the edge of the is a diver at 6. Let's say this is a time of 0.8 seconds. So how far? Now what we know is that this 2, because he went off horizontally, is just in the x plane. So that means that it is ux. So therefore x is equal to ux times the t. Right? The ux is the initial that he drive off with horizontally, and the t would be the 0.8. So we get a 1.6 meters to be the distance that he would have traveled horizontally after 0.8 seconds. Now, what is the vertical distance above the surface of the water if the diver is at 0.8 seconds? So now we want to know, if this is 0.8 seconds, what is this height from the ground or from the water? All right. Now, what we can do is that we can use the same formula we just used for the previous question. Right? Because we know that uy here is 0, because initially only jumped off horizontally. There was no vertical initially. So if we want to find y, then this is 0 plus half of negative 9.81 times the time, which is 0.8, and we're squaring that time. So when we do that, you will get negative 3.14 meters. The negative tells us that we're going down, right? So it's a downward displacement. So therefore, the final answer would be that it's 10 minus 3.14. Right? And to 1 sig fig, this would be 3 meters. So we're minusing 3 from it. So we get the final answer to be 7 meters above the water. Right? Because he is displaced 3 meters downwards. So therefore, he's 7 meters away from the water surface. All right, we go to the next question. It says, at what horizontal distance from the edge of the platform does the diver strikes the water? Now, to know this value, we have to find what is the time it takes to reach the water. So therefore, we utilize the same formula from before. Now this time we're going to find the time it takes to displace 10 meters. Because the height of fall is 10 meters, initial velocity is 0 times that times negative 9.81 times t squared. So what we do is to find half of 9.81, and then we divide 10 divided by 4.905. Then we square root that, so it becomes square root of 2.04, which is to 1 sig fig, that is, all right, let's go 2 sig figs, that's 1.4 seconds. So it takes 1.4 seconds to reach the surface of the water. So to know how much distance it's covered, we use the initial, which is 2, times the time 1.4, which gives us 2.8 meters horizontally that he would have traveled to hit the water. Now the final question is, at what velocity does the driver strikes the water? Right? Now, at any point to find the velocity, unless it is at its maximum, we have to know what's the y velocity and what's the x velocity. And in this case, the x velocity is the vy, sorry, and the ux, or the vx. Now we know the vx is equal to the ux, which in this case is 2 meters per second. So we need to know what the vy is. Now we can take vy, because vy squared equals uy squared plus 2gs, and in s would be y. So therefore vy would be equal to the square root of 0 squared times 2 times negative 9.81 times the displacement, which is negative 10. And that would give us that vy is 14 meters per second. Now to find the v at striking the water, it would be the ux squared plus the vy squared, which in this case would be 2 squared plus 14 squared, which gives us 14.14. Right? So we notice here that the full velocity of impact on the water is 14.14 meters per second. So whenever you're trying to find the velocity of impact of a projectile, it has to be, you find the y and you find the x, then you use Pythagoras theorem to find the overall velocity of impact. So this is where we're going to end for this week. Hope you understand how to use these equations to analyze different projectile motions. And I'll see you next week where we continue to learn on the IB physics syllabus. Thank you.